So here is an example of the similarity transform. We have two frames here, just the example that we did earlier, okay? However, now let's consider RZ, basic rotation matrix, RZ of theta in frame one, okay? And we would like to find the similar transform of it in frame zero. So now our by definition, so notice that we need to post multiply RZ by a matrix and pre-multiply it by another by the inverse of that matrix to get the similar transform of this matrix in frame zero. So we have to multiply RZ of theta by some matrix R, okay? And the top preceding superscript or the preceding superscript of this matrix should be the frame in which RZ is defined, okay, which is frame one, okay? So we have frame one here, and the bottom one should be the target frame, which is zero. We would like to find the similar transform in frame zero. And the other one is going to be this matrix, but it is inverse, okay? It's inverse. So this is going to be my matrix in zero. So let's call it B, okay? Matrix B is defined with respect to frame zero. Now I need to find this matrix here. We in the previous couple of slides, we found R1 to 0. Now let's find R0 to 1 in the same way, or you can go back and transpose that matrix to get its structure as shown here, okay? R0 to 1 is what? Now, what is the x-axis projections of frame zero, x-axis of frame zero in frame one or onto frame one? So we have, this is x0, and it is, as you see, it is completely parallel to x1. So the answer to this is 1, 0, 0, no change, okay? Next, what is the projection of y0 into frame 1? This is frame y0, as you see, and it is anti-parallel to z1. Okay, so z1 is what? Is 0, 0, 1. So it's anti-parallel. So we have a minus sign here, -1. So this is the projection here. Okay, what about z0? It is parallel to y1. So this is going to be 0, 1, 0. So this is our matrix here. And we have our complete, so this one is nothing but the transpose of this matrix. Okay, so I can transpose it on the fly. So we have to let me just color or highlight these rows. Okay, this is going to be column number 1. Okay, so 1, 0, 0. And this is going to be column number 2, 0, 0, 1, 0, 0, 1. And then column number 3 is going to be this one here, 0, -1, 0. Okay, 0, -1, 0. And then you need to multiply this by RZ, which is what? Basically, the Z axis is going to be 0, 0, 1. And here it's 0, 0, 1. Okay, and here it's cosine of theta minus sine theta, cosine theta. And then you multiply this by this matrix, okay, which is R0 to 1, 1, 0, 0, and then 0, 0, 1, and then 0, -1, 0. Okay, so let us do the multiplication from left to right. Okay, so first we multiply this row by this column to get the first element here. So this is going to give us cosine theta, okay, because the other the other values here are multiplied by 0, so it's 0. So only multiplication here that gives us value is cosine theta, which is 1 times cosine theta. And next, row number 1, and column number 2. Okay, row number 1, column number 2 gives us the second column in row number 1. So this is going to be a minus sine theta, and then a 0. Okay. Next, row number 2 with, let me use a different color here, with column number 1. So I'm selecting, just negating the last element here. Here it's 0, so there is no change here. Okay. And for the second column, it's going to be 0 as well. Let's see. Yeah, it is 0. Yeah, it's 0. And then, so why is it 0? Because this times this is 0, this times this is 0, and this times this is 0. So their sum is 0. What about the last one? It is going to be a minus 1, because basically if you multiply this with this, or dot product this vector with this vector, you get a minus 1. Okay, let's dot product this now, the final one, pick a different color here, with these, okay, with these columns. Okay, so 0, 1, 0, it means that I'm picking the second element in the columns. Okay, so this is the first one is going to be sine theta, and then it's going to be cosine theta, and then it's going to be 0. Okay, and this is multiplied again by 1, 0, 0, the second matrix. Okay, and then 0, 0, 1, and then 0, minus 1, 0. And don't forget what we just did is multiplying these two together to get this, and then we are left with this. So now we are multiplying this to get our matrix here. Okay, so what does this mean here? I'm going to multiply this quickly now, okay, because we got the drill now. Okay, this is going to be a cosine theta. Okay, and then it is going to be a 0, and then it's going to be a minus, actually it's going to be, yeah, minus sine theta. All right, and then this is going to be what? A 0, and then a 1, and then 0, right? Yeah. Finally, this is going to be a sine theta, and next it's going to be a 0, and next it's going to be a cosine theta. Okay, as you see, this is nothing but ry of minus theta. If you go back and compare this structure here with ry of theta, let's go back. You'll find that the negative sign is here of ry of theta. So if you have ry of minus theta, the negative sign will be flipped from here to here. Okay, from trigonometry. Yeah, you see it. Okay, so it's exactly the same. So this is exactly what we expected, because basically the similar transform to Z1 in 1 is I mean, the similar transform to for rotating about Z1 in 1 in frame 1 is basically rotating about Y0 in 0. Yeah, hope this is clear.